Hi there, everyone. It's been a while. I got a full-time job now, so the time is like limited, so much more limited than before. Anyways, hope you guys are good, and I'll try to bring in some value here. Getting into the topic of today, flip sims. Okay, I'll try to get here the most easiest but complete flip sim, how to do it for base level things, you know. At the end of this video, you should be able to do anything that you want in the normal flip sim stuff, um, which do not comprehend, so it's not anything that you want maybe, but do not comprehend like oceans and that other stuff, which is done differently. But emitting fluids or doing fluid stuff, you should be able to do everything. Let's start. So like this stuff here, you should be able to do. Okay, let's start on, got a new camera, by the way. It's great. And it's taking me some time because I'm doing photography and videos. So that's even why I'm not here. But anyways, let's get into the topic of today. And I will try to start simple. So actually, to do this thing here, you just need like 10 nodes because you have some more here inside. But you really need like a little amount of nodes. Like this is the easiest fucking stuff ever. We're gonna get into the other stuff later, but to do flip sims, this is actually the essentials that you need. And this one you can maybe even not put it in there. So, you know, this is it. Well, let's start from how it works, okay? Theory. I know that you don't like theory, but I know that I don't like theory, so I'm just guessing that you don't too. How it works. Um, it works like this. You have to have a source. Source. Okay. Sorry, I'm just a bit. Okay, maybe like this might work better. You have to have a source, which is putting out like the stream of fluids. Okay. You have to have the sim, and you have to transform the sim, which is particles, points, and you have to transform the sim into mesh. This is it. Okay, as easy as it can be. Into the sim. So into the source, you can add velocities. You can add more sources. You can add stuff in here, and this can be even animated. You can add animations. Okay. Into the sim, you can add drivers. Not like Ryan Gosling in Drive, but like forces. Okay, you can add curves that drag the particles along the curve, so they do that stuff, you know. And you can add colliders, so the simulation knows that this is a collider. In the simulations, you can even like density stuff, you can set density, viscosity, And basically that's it. Okay, into the meshing part, I'm gonna show you the easiest one, the the one that you will be able to do like 80% of the stuff with, so it should be okay. Okay, wait, like super easy. uh, and it can be VDB if you want to. I don't know who the fuck uses but it can be VDB, and it can be mesh, like polygons. Okay, that's it. This is how it works. So basically you just need 1, 2, and 3 things. That's it. Okay, let's get into the good stuff now. And we start now with uh, your source. Sorry, I need to get this board over. Okay. So at the moment, my source is this box. Can be anything. Can be, as we was saying before, can be like even moving, animated. You can transform this box, transform it, and say like the box is here at this time and moment, and at this time and moment is like there. You know, get it here, and it works still. So the box is moving the whole time and emitting particles, emitting fluids. It works. Okay. Um, can be even like here. I will show you after. It's a bunch of people doing crowd stuff. Okay, so moving like a crowd, etc., etc. Can be even this your source. Can be anything that you want. Can be your source of fluid. Okay, so let's start with the box. Really easy, really simple. What you do after the box, after your geometry of choice that's going to emit the particles, you go with a flip source, flip source, flip source, dop, dop source, flip dop source. It works anyways. If you search for dop, it's gonna get out. So flip source from your starting point, and in here it's important the voxel size to be a right amount, which is not too much, not too little, but the right amount to define like what is your shape. So here 0.1 is good because it's defining my shape. Maybe if I do like here 1, it's not that good because, you know, it's not defining greatly my shape. And if I do like 0.01, it's excessive because I don't need that much of detail from my shape, because anyways it's gonna put out like particles and they're just gonna be like wobbling, so it's not important. And 3 millions is a bit exaggerated for a box like this, so 0.1. You decide like that based on the shape of your object. Okay, so if it basically it's the same shape, it's cool. Particles, this will be really important, but to see that, because not actually we now see here 3000 points, but to see that visually, we need to blast the surface. So go here, blast, you go surface, and now we see only the points because we don't really need the surface. But the surface, if we do like before, see, if we do like this thing, this that is going to be our source, which is points. The first big thing there will be points. Okay, so this will be our source. It's different than it should. It's not a cube. It's not like a. So that's why voxel size is decently important. Okay, so get a decent amount of precision with it. 0.1, you see, it's changing nothing, so it's cool. Another important stuff that I do here, particle separation, we're gonna bring that in a second, but another important stuff here is, here I do $FF almost every time. so the source every time moves. See? Because if you don't do that, let's see if we don't do that, what happens. Okay, let's get into our source, let's get into the simulation and see what is going on. Okay, look, I think we are doing that. Sorry, yeah, we are doing that, and you can see that our simulation is pretty okay. But if we don't, and leave this to 0 to 1 to wherever you wanna leave it on, look how our simulation is. So you see the trails. Basically, $FF here tells to move the particles to the position of the particles. Is going to be every frame, every intra frame, it's going to be different. Okay, so you can do $FF or $T, which is basically the same stuff in caps. Okay, I do that every time. And here I added some velocity, so you just go point velocity, okay, just to spice it up. You don't really need it, but just to spice it up. Now let's see, this is the velocity vector. Without it, wait, sorry, and keep incoming. Incoming was 0, so it's keeping 0, okay. And you can add velocity here and make it point down, up, wherever you want. So you can point the direction of your flow, okay, from here. And every time it's gonna like emit particles for the fluid simulation, it's gonna emit that in using this velocity. Okay, so this is the easiest way to directionate the first stream of your thing. Okay, keeping coming. You can add curl noise, which is spicing up a bit the thing, and I usually go with animated. Here you can how much you can like decide how much the pulse duration is, like the noise, how large is the noise in the time. I hope that's clear, but you can try that. Just to be clear, here we are not just we are just I'm just gonna try to make you understand what the fuck is happening, why is that happening, how to do things. But um, the little tweaking and making like perfect simulations and stuff, you do that yourself because it takes a lot of time. And with this knowledge that I will try to get into, uh, you can do that. It just needs a lot of time of tweaking, of like this a bit more, this a bit less, this let's try that, let's try this. Okay, so I just put it up point velocity there, and here it was like an attribute wrangle, because I used to have like a smaller velocities, and with this point wrangle are way much, because now it's vector v, which is vector velocity times 10, so it's 10 times the. If you want to have something, because if you can see here, if you have like different type of velocity, let's say you have it like this, if you want to increment that, you have to do this times 10 and the other one times 10, and then maybe scale even this. Okay, so usually I just go with that, or even better, yeah, you see, it's easier. So every velocity is times 10, or even better, you can go here and do CHF, which is channel float, and do like, fuck me, do like this, and sorry, and do like this, and tell him like val, we're gonna call this value val, and add here, and now you have a channel that gives you the power to decide v at v how much it's gonna be amplified. Okay, hopefully that's clear too. Anyways, that's the source. That's it. That's it. 100%. Okay. So now we have a source. Now we have sorry, let's just keep this 0 and this like minus. No, never mind. It's 0 even this one. Let's see. No, fuck me. 2. Okay. Like this. Yeah, nice. It's cool. Maybe the scale a bit less. Okay. And now you just have to open a .NET. Okay, let's do that. So now we're getting into the simulation step. Second step, easy as fuck. I hopefully it is. Tell me if that's what's like easy to understand. Oh, sorry. No, I'm missing the particle separation, which is the most important fucking thing. Particle separation here. Watch out, because this is a relatively important and delicate value. Because if you go here, like if you go too much down, it's going to be a lot of points. Like this is the amount of points that each frame is getting out. Not this number, but this number here. Like points, I have 5,000 points here. Okay, so here this decides the precision, the amount of points, and the beauty of your simulation, usually. So the much points you have, the much better the simulation, but the much slower it is. So you have to find your own way. With my PC, each frame from 5,000 to, I don't know, 100,000 to 200,000 for each frame, it's cool for a basic stuff. If you want to do a great simulation and it's not like too much frames getting into that, you can do like max 10 million points, not each frame, but max like your roof. If you in 100 frames get to 10 million points with a decent PC, you should be able to get things done in not too much time and exploding your PC and stuff. So basically that's it. So the much more points you have here, the slower is this number, the much more points, and the better your simulation. Let's do this like that. So 10,000 points is good. This is our source, okay? Let's get into the simulation part. Simulation part, you go DOP network. We got each one of these things. Point 1, source. Point 2, simulation. Point 3, meshing. You can do those in like at least 10 ways, okay, for each one. This I think is the most complete and the most easy, because it gives you like power to do things as you like, power to change stuff, power to get colliders as you want, to get like forces as you want, to change your simulation easy, to not be bound to stuff that other people has done here in the particle fluids, how they do that, and to understand everything and still being able to not have it that much complicated. So this is it, okay? So .NET, you can do this in other 25 fucking ways. .NET, you get into that, and here you need object fluid, flip object, sorry, flip object. You need a flip solver. You need a volume source. Okay. So volume source and flip object is the same fucking thing, basically. Okay, don't ask me anything about it. Why? Don't ask. It's the same thing. So this is gonna be your source. You have to just tell him, because he don't know, as we evaluated in old video, which was like sop dop nop top etc. context. Each context usually doesn't know about the other ones, so you have to tell him. Here we're gonna put the source. Okay, source here you go with. Let's go with the first one, flip object. Okay, particle separation. Usually people do copy this parameter and paste it in the source phase. Paste it here. Okay, because it has to be the same one. But I think that's stupid because every time you have to change it, you need to go into the .NET. And every time you get into the .NET, if it's full of fucking things, it has to recalculate all the things. So it's way slower. I think you do the opposite, and I usually do the opposite, and it works. So I take this value and copy parameter and just get into my .NET and paste it here. Paste relative reference. This is linking the two parameters. So each time hopefully you know this, but if you don't, each time I change that one, it gets this one changed to automatically. Okay, so that's it. This one's for now, leave it like that. Just let's get the easy stuff because it's gonna be a long video anyways. But hopefully we don't getting the fucking 5 hours thing. Here I go with particle field. Particle field, yes. Here you have to search for your source. Okay, so this is my source. I go just usually Control C, Control V. Okay, so now he knows. And let's see here, particles. Oh, let's just put it like this. Okay, now we can see my source. If let's just go one step behind. Okay, you cannot see that because it wasn't there, but now he knows particle source. And usually I get here and see these as particles, which is way better for me. I like it more. And I leave everything else like that, like it is. Collision offset. We're gonna talk about this later. Let's do the same thing here, which is volume source. You have to tell them which is your volume source, which is the same. You can just go from here, copy that, go here, paste that. Or if you want to do it parametrically, you can just okay, you got it. You can just paste relative references, so it's gonna be every time the same thing. Should work, I guess. Maybe it doesn't, but we are gonna find out. Okay, let's think that it will not work. I don't know if it worked. I should be, but anyways, we just go C, Control C, Control V. Here you go source flip because it's giving attributes under, which gives like the solver the ability to solve stuff, to understand that what this is for real. And that's it. That's it. Oh yeah, if you want to get this, because now it's streaming 24/7. It's streaming particles. They getting each frame. If you want like a 10, if you can see that now here, okay? Blah, 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 particles working. Yeah, okay, but it never stops. If you want something that happens one time, you can go here and tell them $F under something, or usually, because I don't, sorry, I have a problem with my keyboard. With those keys, the under and the, okay, minor, okay, it works. Not that type of mine. Okay, minor than like 5. Okay, so it's gonna be 1 until frame 5, works till frame 5, and then doesn't go anymore. Okay, so you can do that and do it for just one frame. So it's gonna be just for frame 1, frame 2 it's already not there. So that's it basically. Let's just take this. Okay, now it's active every time. Flip solver here. Okay, now you have, if you go like this and you check the flip solver, You can see the cube, maybe you don't, but you can change the cube. The cube is the domain. Is this cube is where the simulation can happen, where it works in the space, because it doesn't work everywhere. If I take my source and put it here, it doesn't work. So if you don't see your simulation, if you don't see your points, if you have done everything else correctly, and maybe your scale of your stuff, of your source, it's different than the normal scale, maybe it's outside of the box and you don't see it. So just check out that it's inside the box, which is the domain of the simulation. Flip source sim. Okay, we have done everything here. If you want to get this bigger or smaller, you can do it here. Okay, with that.